Hello everybody, this is Adrian from Mac Design League, and I'm just going to be making a video version of the second workshop, which is for assembly. I'm just going to hop right into it. Actually, before I do that, if you don't have the files from the first workshop, which chances are you don't, you just go to this link and they will all be there. You can download them up in a zip and then just extract them somewhere so you can use them, and then you'll be all set to go. You'll have this one and a number of other parts as well. So today the workshop is on assembly. So currently I have a part open. It's just one of the parts we're going to be using today. We're not actually going to be editing in part mode. You can tell if you're in part mode because of all the tools up here that you have, like extrude, revolve. Those are all for making parts, obviously. So our first order of business will be going up to File, New, and under Metric, and you want to select Standard Millimeter.iam under Assembly. Ignore everything else. This is what you want. You just double click it, open it up. It'll take you like 10 seconds for your computer to load it, and then you'll be in this workspace. It's the exact same thing as like your standard part workspace. You have your three planes. You can look at them like this. You can rotate it around, same deal as always. So what assembly is basically you just assemble a bunch of parts together. You won't have to make any edits to the parts themselves. You basically just define how they are placed together. Now, I can't really do anything at the start without actually having a part. So let me just place that into my assembly. So you go to Place, and you want to navigate to wherever you have the workshop files saved from where you downloaded them. So once you've extracted them, you should have a folder called Workshop 2 Required Files, wherever you intended to save them to. Go into Workshop Required Files, and you'll have all these parts here. Now what we're going to start out with today is we're just going to go to arm.ipt, double click it to open it up. There'll just be like a ghost of this part kicking around somewhere. Just click it once to place it onto the screen, and bam, look at that, beautiful, gorgeous. It's even got shimmering edges like a steel part. And as you'll notice, you're still in the tool. You can tell if you just like click another one of those around, that's not what we want. So to exit out of this tool, you can either do hold right click and then ghost over to OK, or you can just click the escape key. Bam. We actually only want one of these though, so just click on one of those, press delete. You can just press the delete key on your keyboard, or you can right click it and say delete. Easy peasy. Now, a good way to start any assembly is to have one part you want to use as your base part and everything else towards it. So, if we wanted this part to not move, everything else should be in reference to this part. Right click it, and you go down to grounded. This is a very big menu, just find grounded in there. And when you click it, what it does is it just makes this part, even when you try and click and drag it somewhere, it will not be able to be dragged. If I disabled grounded, I could just move it around however much I wanted, right? Because it's not grounded, obviously. That's what grounded means. So once we have our part grounded, won't be able to move it. You can check it out however much you like. One change I'm actually going to make, because I find it easier to work with my parts, so I'm going to go to View, and I'm going to change Visual Style to Shaded with Edges. You can see it brings out all the actual edges that you can work from on your part. It makes it a lot easier to visualize what you can select when you're doing your constraints in assembly. So once I have all this selected, I'm just going to go back to Assemble, and I'm just going to go over a brief snippet of how you can, some easy ways to navigate around your part. So you'll see up here you have the cube. This is your design cube. If you click it anywhere, you've probably used it before. I'm assuming you've used Inventor before, and you can use this cube to change all your orientations. Now, there's a few other ways you can rotate it around. Basically, the principles of CAD involve spinning things a lot. So there's obviously a lot of shortcuts for this, and you'll definitely get better at being able to navigate it. Obviously, zooming in and zooming out with your mouse wheel will help a lot. It's a great tool to have. So make sure you have a mouse. If you try to CAD on a trackpad, I feel sorry for you. Another way, if you do have a trackpad by any chance, go over to this. It's called the Orbit tool. And you can just drag it around with left click. Simple, easy peasy. Drag it around. You know, pretty self-explanatory. Of rotating your part around is to hold shift. Sorry, this is only if you have a mouse, but if you hold shift and you hold the scroll wheel of your mouse, so that's like the middle button, if you hold both of those down and you move around your mouse, you can actually rotate it extremely precisely and do whatever you want. Let's say I wanted to look at inside this hole. Bam, I can look inside the hole. It's very, very fluid, you'll find. It is quite annoying holding shift, but as long as you're set up in a comfortable zone, you have a desk and everything, it shouldn't be too big of a deal. So I'm just going to go back to this view, our default isometric view. Now, what I'm going to do now is I'm going to start putting parts together. Currently, this is one part. It's just got a few threaded holes and an emboss in there. We want to put some bearings in this thing, because well, I'm actually going to keep it a surprise as to what it becomes later, but we're just going to put some bearings in this. And basically for any fastener or bearing, anything like that, bolts, a really great website to go to is called McMaster-Carr. You can see it right here, and as you can see, there's tons of different stuff you can select from. Right now we want to select a bearing. So, for the purposes of this workshop, just go to McMasterCarr.com. You'll see a search bar up here, and search 6391K126. And when you do that, it'll bring you to this almost spreadsheet-looking thing. And when you go down here, there will be a window opened up under one of the parts. This is the part we want. It's got the part number here. And so what we want to do is we want to get a CAD model of this bearing, and we want to put it in Inventor. So to do that, we just go hover over here, Product Detail. You'll see a little symbol next to it that says CAD with like a little target. Just click it. Easy peasy. It'll take you to this page. It'll give you a nice little drawing of the part, show you all of it stuff that you probably don't care about if you're in first year, but these are all lengths, outer dimension tolerances. It gives you a really simple drawing here. And what you want to do is you want to go to this drop-down menu right up here, as long as you can see it. Hopefully you can. And I believe it'll probably be defaulted to 3D SolidWorks. You want to select 3D Step. Now, a step file is a kind of CAD file that any CAD program can use. So you can, if you wanted to use a part from SolidWorks and put it in Inventor, you would save it as a step file, and then you'd open it up in Inventor as a step file. So the step files are really handy for that. So click Save. It'll download. Then you're going to put it in the same folder as all your other Workshop 2 files. Bam, it's in there. I already have it saved, actually. So then we're just going to exit out of here. Now we're going to go back to our assembly, and we're going to go to Place. To place your tool, see, when you go into Place, it'll have it automatically selected that you can only select Inventor part files and Inventor assembly files. So we're going to go up to Files of Type, and we're going to scroll through this big list until we find step files. It should be right down the bottom in the S's near STL. Click it, and you should be able to see your bearings. I'm going to select this one I just downloaded at 5:20 p.m. and it should open up this menu here. It should automatically have all of these settings selected, but if it doesn't, make sure your settings look exactly like this. Make sure Convert Model is on. That's the most important one, because it converts your step file to a workable part file in Inventor. So once you have all this selected, click OK, and bam, it'll come up exactly like the part you had before. So place the bearing down anywhere, same thing as always. Make sure to press escape to exit out of the tool so you don't place a ton of them. And here we go. We have a bearing which we can actually move around because it is not grounded. But this, we still can't move it. We still can't move it because it's grounded, and that's exactly what we want. So once we have our bearing in, we need to find a way to, what we want to do is we want to put this bearing in this hole. And there's a number of ways you can do this. We usually for bearings, you want them to either, like, for the purposes of this, we want it to be rigid in this hole, let's say, so that it's in the hole, it can't move out of the hole, nothing's going to get it out of there. So, nothing's going to spin inside. So, there's a number of ways we can do this. We can use the joint tool, which automatically determines the relationships between your component and your assembly, or we can use constraints, which allows you to more specifically adjust how the parts interact with each other. I'm going to start out with the joint tool because it's super duper easy. So we go into the joint tool. It comes up with this interface. You'll see you can connect your first origin, your second origin, and then it'll ask you for your type. So like I said before, we don't want it to spin or anything. So the type of joint we want for this case is a rigid joint. Click rigid. Keep gap at 0. Now, for the first selection, select your bearing. Make sure it's your first selection. When you're going to select it, it should come up with these like little green circles that don't exist. This is just this showing that you're selecting the circle, like the extrusion. Select it. It'll come up with this, and it'll automatically select your second component option. And for your second component option, we just want to do the same thing with the hole on the arm, right? Right here. And bam, it'll give you this nice little animation of the bearing going into the hole and showing that it can't move around. See? Once you've done that, click apply. And bam, we have a bearing. When we try to click and drag it, it does not move. That's exactly what we wanted. But sometimes things aren't that easy. Sometimes the program isn't as smart as you want it to be. So I'm going to show you a different way we can do this. First, I'm going to click Ctrl-Z. That just undoes the joint that we made. Another way we can do this is with constraints. So if you go into the constraint tool, you'll see that there's a billion different options. You'll have mate, angle, blah blah blah, all this stuff up here. Well, let's keep in assembly mode for now. And what we're going to start out with, let's start out with a mate. What we're going to do is we're going to mate the cylindrical axis, let's say, of the bearing with the cylindrical axis on the arm part. And it's actually super duper easy. You click, you hover over the hole on the bearing, same way you did for the joint. It won't show up with a circle this time, but that's okay. Click it, do the same thing on the arm, bam, it'll play this horrible noise, and it'll pop your part into place. Once you click apply, exit out of the constraint tool, you'll be able to see that it can still move through and through, like this. That's not what we want. So, we need to figure out a way to align this face with this face, or somehow tell the program that this has to fit inside the hole and can't move anywhere. If you want, you can go up to, I believe it's under View, and you can see the degrees of freedom of your part. And right now we can actually see that it has a degree of freedom. It's hard to see here, but it has a degree of freedom going this way, and a degree of freedom on its rotation. So let's turn off degrees of freedom. Go back to Assemble. First, we want to deal with the whole back and forth problem. So we're just going to go back into the constraint tool. If you look at the graphics for mate and flush here, you'll see that the mate has opposing faces connecting to each other like glue. But flush basically just tells two faces to be aligned to each other. So if we want this face to be aligned with this face to fit the bearing in there, that's obviously what we want, right? Because we we can't tell this face to be locked with this face, and we can't tell it to be locked with this face. So let's use flush. And what we want is we want this face on the bearing to be parallel with the face on the arm, right? Click it, plays the horrible noise again, it pops your part right into place. Now, we can't move it back and forth, but despite what it graphically looks like, I can actually spin this part. It is currently spinning. It's hard to tell because it's completely uniform around, so the graphic doesn't change. But if we go up here, we can actually see in degrees of freedom that there's still the little rotation thing. So we want to get rid of that stupid thing, right? Let's keep degrees of freedom on for now. So how the hell do we get this thing to stop rotating? If we go into constraints, we can't use a mate, and we can't use flush, because there's no faces to connect, right? But if we go to angle, you'll see that there's a few options here. And if you look at the graphics, this one in particular, directed angle, will be your best friend, especially in 1CO3, when they make you make a PDF of all your constraints of your degrees of freedom and everything like that. So you want to use directed angle, and what this does is it basically tells you, or it tells the program, what the angle between two flat surfaces should be in a very easy to understand, direct way of putting it. So, well, we don't have any faces to really tell it to do that with right now, right? Because we only have the front and back faces. So, what do we select for the directed angle? Well, let's exit out of the tool. If you go over here in your design tree, hopefully your design tree shows up. If not, if you don't have this toolbar here, go under View, you go under User Interface, and make sure all these are selected. Make sure the same things are selected as me. You go back to Assemble, click the arrow under here, click Origin. What we want to do is we want to find a plane. So let's look at some of these planes here. This plane sort of slices right through the middle, the XY. So that's a good one. Our XZ lies. This one looks pretty good to me, actually, because what we want is we want to say that the plane in this bearing has to be parallel with the plane on the arm. So I like this plane. This looks good to me. Once you have enough CAD experience, you'll be able to visualize it more. But if we say looking at that plane, well, we could use that plane too, actually. So either one of these, let's select XZ for now. We're going to go to set the visibility to on so we can use it later. And do the same thing, make sure it's the same kind of plane for your big arm part. So the XZ plane, that's exactly what we want. And here we go. It'll create this giant orange catastrophe. Go back to Constrain, directed angle under here. Sorry I did that a bit fast. Just go back and see what I clicked. And exactly what we want to do is we want to select the plane from this bearing, and we want to select the plane from the arm. These will be a bit hard to select. Make sure you're selecting near the very edge of the plane. Click them both. Make sure that's set to 0. Look, it automatically made this plane flat. Now, once we click Apply, we hide these stupid planes. You have to go back over to the toolbar to hide them. That's the easiest way to do it anyways. If you go back to View, you'll see our degrees of freedom are on. That little circle thing is gone, so that's how you know you've done it correctly. This can't be spun. You'll see the little crossed out circle there. That means it's not spinning. There's no degrees of freedom. Bam, we have exactly what we wanted. So let's move on to the next part. We're going to go back to place. So it's automatically in place imported CAD files because we placed a step file earlier. Go back to regular place. And set it back to IPT here. And what we're going to select this time is we're going to go to our 9125 9A535 blah 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 shoulder screw. Click it. place it in your assembly, hit escape. I'm going to turn off degrees of freedom because I personally don't like having them on, but if you like having them on, keep them on. And now we have this shoulder screw in here. And what we want to do is we want to thread this shoulder screw through our, oops, I accidentally double-clicked the part and that opened me up into the edit part mode. So that's another thing. Actually, I'll just do that real quick. So, if you want to edit a part that's in an assembly, just really quick, just select it in the sidebar here and click open. Easy peasy. You can make whatever changes to the part you want. I'm not going to change this because obviously I want to use it in my assembly, but as you can see here, we have all the parts, all the tools here we need for changing parts. You can make an extrusion through the cylinder if you wanted for whatever reason, and when you're done you can just close it or just go back to your assembly down here. Now we want to actually place this shoulder screw inside the threaded hole of the arm. Make sure you don't place it in the part with the bearing. There's no threads there. It can't be placed inside. It can't be placed through that hole. So, go to joint and go to rotational this time. We don't want it to move around. We want it to be able to spin through these threads. So go to rotational, and the part we want to select on this screw, we want to align it up with the hole on here. So a good way of telling it how far through it should go is to select a face on the screw itself. So if you rotate around and you find the bottom flat face of the head of the screw, if that makes sense, and select it, just like that, and you'll find the same, and you find just the regular hole on this side of the threaded hole, and you click it, it'll give you this nice little animation of the screw fitting into the arm part. And that looks good to me. Click apply, and bam, we have a screw in the hole. It can rotate around. That's exactly what we want. Interestingly, if we unground this part and we ground this part, this will actually rotate around the screw. And that's exactly what we're going to want. You'll see at the end of the video what this is actually going to be used for, and then it'll all make sense to you. We want this screw to be in place, obviously, because that's what screws are for, and we want this part to move around. So good, we've done exactly what we wanted to do here. So let's move on to the next part. Now we want the next part for our little sub-assembly here. So we're going to go to place, and we're going to go down to road wheel.ipt. It's this big black mass. Click it, and place it into your assembly. And now you'll see we have this big-ass wheel in our assembly. What do we want to do with this? Well, basically what we want to do with this is we want to put some deep groove ball bearings inside this wheel, because it's a wheel, and that's exactly what goes inside wheels. So where do we get these deep groove ball bearings from? So, a really quick way that Inventor implements bearings and other fasteners into its program is if you go up here to design, you'll see all these things that you can put into your assemblies, and they're very handy. They've got gears, which is probably what you use often. Another good one is disc cams. You'll probably use those in the second year. And you got bolted connections, clevis pins, all this stuff. Now, what I said is we wanted a deep groove ball bearing, right? So go up here to bearing. It'll prompt you to save your assembly, so I'm going to do that. I'm just going to name it Workshop 2. Looks good to me. Click yes to all. I always click yes to all. It's not too important. It'll tell you the data format of the step file is changed. Just click OK to everything. Inventor just likes to get worried about stuff. And now your bearing window will pop up. So basically what you've got to do in this window is it's got a bunch of bearing files saved in Inventor, and your only job here is to tell it the outer diameter and the inner diameter. That's all we want to do right now. So I said earlier we want deep groove ball bearings. So up here you'll see that it says angular contact ball bearings. Click the drop down menu. and change the category to deep groove ball bearings up here. That's all we want to do. It'll take you back. Whoa. Sometimes it's stupid and it doesn't save the selection for you. So just try it again. It's good that that I'm making these mistakes, or well, I guess that was the program's mistake, but it's good that this happens so you guys know. So once you have deep groove ball bearings selected, just click the yellow folder. That'll change this up here. And bam, this is what we want. So now we want to define what outer diameter and inner diameter of the ball bearings we want. And this will kind of depend on what the dimensions of your wheel are. But for mine, my outer diameter I want to be 22, and my inner diameter I want to be 8. So fill out the fields just like this, 22 in both the from and the to on the top, and 8 in the from and the to in the middle row. Click Update, and it'll give you a semi-brief list of ball bearings. And you can pretty much choose any of these. For the sake of this tutorial, I'm going to click the simple one. As long as it says 608 on it, that's what I want. Click it, click OK, click OK. Now you'll see there's a ball bearing ready to be placed. And we want 2 of these, so click it once. And as you can see, it doesn't work the same way as the place tool does. So what we want to do here is we just want to click and drag, or just select it somehow, right click it, click copy, and then right click anywhere on this open space and click paste, and bam, you have 2 of these suckers. So now let's place these bearings inside the wheel. Now for the purposes of this, I want my bearings to be rigid inside my wheel. So I'm going to click joint, the easiest tool we can use here. Change the type to rigid, and click. Now we get to decide, do we want to click this outer face? Do we want to click this inner face? Or do we want to click the axis? So this will kind of depend on what part you're placing your bearings into. But if it's something like this, I'll say for the purposes of this tutorial, it's not too important. That's more of your own design question. So I'm just going to select pretty much any of those. I selected the inner face. And now I'm just going to select the hole on the wheel. And I should place it in like that. If you click apply, you should exit out of the tool. We can see that this is in here quite rigidly. These are connected together. These aren't grounded to anything yet. We will ground them to something soon. If we rotate around, we'll see that there's pretty much exactly enough space for our next bearing. So that's really nice. Let's just place the other bearing in there with the same method. So go under joint, click rigid, go down to your bearing, click the face, the same thing we clicked for the other one. Find the proper placement for your bearing inside the wheel. I'm going to choose this one. Looks good to me. Nice, it goes in there. It's nice and rigid. Now we have 2 bearings inside our wheel. So what do we want to do with this wheel? Well, basically what we want is we want this wheel to be along this bearing here, and we want this screw to go inside something so that this can spin around with the wheel attached to it while the screw remains still. So we're going to import another part in here to somehow fasten these bearings together. Alrighty, so like I said before, that under the design part, there's a bunch of default stuff that Inventor has saved that will let you place uniquely designed pieces into your assemblies. Another great resource Inventor has is if you click the arrow under Place Component, you'll see that there's an option called Place from Content Center. And that sounds very spicy, so we're going to click it. It'll take you to this window. I have a bunch of stuff selected already from the last, when I went through this earlier, so I'm just going to go up to fasteners. Make sure you're in the fasteners window. Make sure you go to bolts. Basically what we want is we want a bolt to go through our bearings and connect them together. So go to bolts, go to hex head, and yours probably won't look like mine right away. What you want to do is you want to go up to here, click the down arrow on filters, and select ISO. And once you have ISO selected, it should look like this. And the bolt we want to use for this workshop is ISO 4017. Click it, and it'll let you place it anywhere in your assembly. So just place it somewhere. I know it looks rather tiny right now, but don't worry, we can change it after. As long as you click it somewhere, this window will pop up. And this here, the thread description, basically tells you, or basically you tell the program, depending on what you pick here, how wide the bolt is. And this tells you how long the bolt is. So, for the sake of this, we want to select M8, roughly 8 millimeters in diameter, and for nominal length, we're just going to select 25. Click Apply, and bam, it's got this nice big bolt. Click it, place it anywhere. Press Escape to get out of that. And OK. Press Escape again. Just, if it keeps popping up, just press Escape. Escape is your best friend in Inventor to just go back to 0, no tools selected at all. So now we're just going to rotate this around. We've got it sort of lined up with the wheel and the arm. How do we place this bolt inside the wheel? Well, if your guess was go to joint and make a rotational joint, you would be exactly correct. So we're just going to do exactly that. We're going to click the underside of the head of the bolt again. Make sure it kind of looks like this, so that the face is outlined. Click it. It should go all ghost mode on you. And then you do the same thing with the face on the bearing. Make sure it's the inner face. And as long as you selected rotational joint, it should give you this nice little spinning animation. And once you have that, just click Apply. Now, we have a bolt and a wheel, but we don't... What we want is we want it to be secure in here, and we don't want it to tear anything, right? So what we want is a washer on the underside of this. Click Place from Content Center again, and this is where I was. The window where I was earlier is if you go here on the side and you click Washers and you go to Plane, you'll see that there's, and as long as you have ISO still selected, these will be your selections. For this tutorial, we want to use ISO 7089. Click it, and don't place it in your assembly yet. It's a neat little trick I'm about to show you. So if you rotate it around, hopefully you have some method of rotating it around while you have the tool open. And if you go down here, and if you navigate it around, you'll eventually be able to select the inner diameter of the inner face on your bearing, just like this. And once you have this little selection, make sure you can select it. Bam! Click it, press the check mark, and your washer will be placed on there. Look, we have a washer. It's in there. If you go under the washer, you'll see that there's an insert constraint automatically within it. If we go to View and Degrees of Freedom, we'll see that this can actually still rotate it around. You already know how to change that. You just go to the planes and you do the directed angle. I don't really feel like doing that right now. If you want to know how to do it, just go back in the video near the start. Now, once I have this little sub-assembly all set up, and I want to attach it to here. Alrighty, so how do we put these two assemblies together? Well, if we just pull on each of the parts in here, we'll see that they actually all move together, and you cannot move them around. So, go up to Joint, And we want another rotational constraint, because like I said before, we don't want this to be stiff. We want all of this to be moving around the screw. So go to rotational, go down to the other side here, and click the underside face of your washer. Make sure it's the outer face. Click it. It should go all ghost mode on you. Now go over back here onto the arm, make sure it kind of looks like this, and click the outer face of the bearing that you placed in at the very beginning. Click it. Sorry, that's actually just the animation. So the animation will show only the washer coming. That's just because it's a tricky little thing with joints and constraints. They don't play well together. As long as you click apply, bam, it should show up. It looks nice. Looks good to me. Exit out of the joint tool, play around with it, and look, it moves around. It's great. It's gorgeous. I love it. I love it so much. So this is a nice little assembly we've got going on, right? This is really nice. So let's move on to our next part. After you click save on this assembly, yes to all, we're going to open up another assembly from the required files. So go up here, you can just click on open or Control+O if that's your gist, and click on tracked vehicle. If you have thumbnails on, it should look up like this orange treaded thing. Click it. And now you might get this menu pop up. If this gives you strife, hit skip all. We just want to tell it to shut up. That's basically what you want to do with Inventor all the time. Yes, I think. Okay, good. Good. This is exactly what we want it to look like. So, once we have this assembly open, basically, if you see here, do these look familiar to you? They should. This is the part we just bloody made. So, basically what we want to do is I just want to show you how to place more of these in these little through holes that we have here. So, I'm just gonna reset my view, and I'm gonna place. Go under the arrow here in the place tool, hit place, and go and find wherever you saved the previous assembly. See, I'm having trouble remembering. Where did I save it? Aha! Here did I saved it here. It's called workshop2.iam. Double click it and place it in your assembly. Now you might notice that I actually want two of these wheels, but don't worry, that's going to come back around. So once I have it placed in here, I'm just going to line them up. This is a nice little it's a good habit to get into, is just line your parts up before you do the joints and constraints, because it just makes the program it makes its life easier, so it doesn't have to know exactly what you want it to do, so it doesn't have to flip around the parts. If you try it out without lining it up, you might see some weird stuff going on. So it's a good habit to get into, of just lining up your parts the way you want them to. Remember, you can always just click the part, hit G, and they all spin around. Oh, see, now I've gone and screwed it up. Okay, there we go. Now we basically want this screw to go into this hole and spin around. So, what does that seem like? It seems like a rotational joint. You'd be exactly right if you guessed that. Go into joint, click rotational, like we've done a few times before now. Let's select. See, what do we want here? Do we want the arm to be on the hole, or do we want the screw to be on the hole? Now, like I said before, the arm is supposed to rotate, and the screw is supposed to stay in place. So let's put the screw in there. Oh, I might have selected the wrong thing. No, I think I'm good. So, go over here, find your hole, and place it in. Looks like it's rotating nicely. If we analyze the ones we already have, you can see that we actually want the arm to be selected. So, good old me, I've screwed it up. Let's go back. Don't play that animation. Let's select our first component again. And to do that, if you want to just save the selection that you have of the whole, you just click back here, back to first origin. Yeah, keep the second. Don't touch the second origin. Keep the first origin. Let's go back. Let's select the. If you see this ring here, that's actually selecting the diameter of the extrusion or the bearing that's in this hole of the arm. So if you select it, it'll go back into the assembly. Sorry, that might have been a bit spooky to look at. But if you play the animation, wow, that's really smooth. Wow, that's really nice. I'm just going to play it again because it looked so nice. Gorgeous. Hit apply. That's exactly what we want. Look. But if you'll notice, we only have one. What's the deal with that? So you'll see that these ones, they don't exactly look like the same part, do they? So what we want to do is we want to go over here and we want to do the mirror components. Click mirror. Now, here's where it gets a bit tricky. Mirror tools in most programs aren't exactly the most user-friendly things, but we'll try to keep it as simple as possible for this. So we're just going to click on the component we want. You know, we're gonna make this really easy on ourselves. We're just going to click the component, and we're going to click mirror plane. We're going to click mirror plane and select this face, and it should look like this. Leave all this alone. For some reason, this part it doesn't play nice. So we're going to click next. Click OK on this absurd selection screen, and we've got a part here, and we're just going to attach it to this hole the same way we did with this part. Go to joint, go to rotational. Sorry, I'm going through this rather quick, but slow down the video or go back in the video to when I did this before. Just place it in here. It rotates around exactly how we want. Looks pretty good to me. That's my favorite saying, by the way. Looks good to me. There we go. We have two wheels placed on this little track device. Looks pretty nice. Now there's one more thing. Sorry. Now, there's one more thing that's actually not right with this assembly. If you notice that there's these stupid little numbers up here and little projected lines, it's pretty hard for me to select them right now. You'll see. Well, let's analyze this. Let's examine it for a second. So why does this look unfinished? Well, if we go to the other side, oof, there's supposed to be bolts here. Anyways, what we want to do is we want there to be bolts upon these points here. Basically, what we want is for those points to have bolts going through them through a hole and have some washers around them. So we can do this in like opening up the assembly, making some extrusions, importing some bolts, and constraining them in there. Or if we just have these points, we can do it in a really quick and easy way. So to make this easier on myself, I want to just select this green motor part, right? So I'm going to go up here in my assembly. I'm going to see what the heck that part is. I'm going to find it eventually. Go under hull. Go under motor collar 2. And we're going to right click it and click isolate. It'll come up with this window here. Click OK, like everything else. And bam, we have it nice and isolated so we can work on it easily. Now, what we want to do is go back to your design tab, go to bolted connection, make sure this is on point. Click. So it'll come up with these two selections here. We want to start with our start plane, and that basically says like where does the bolt go into into a hole. Where does the hole start? So in this case, our hole will start on this flat surface. So click that flat surface. And next to our selection, it'll automatically select it for you, is the points. So if you have these points here are all part of the same sketch, handily enough. So if we click one of them, yeah, there we go. Once we click one of them, they'll all be selected. I know it doesn't look like that with the arrow, but trust me, they're all selected. Rotate your part to the back side, because now we want to do the termination, and this is where the hole ends. We don't want the hole to go forever, so we want to select a termination for it. Click the last plane on the underside here, and it'll give you this preview of like these thick looking holes, these big bad Jacksons, and we just want to trim these down to size. It'll show you over here what hole diameter it's using at the current moment. So I believe for this we want to use isometric profile. Go to 3 millimeters, and as long as it looks like they're going through all, you should be good. And you can do it up here as well. As long as this type up here is selected, it should automatically be selected, then you're good. Now up here it says we have some drilled holes, but there's no fasteners yet. We haven't told it which bloody bolts to use. So we're going to go up here and we're going to click to add a fastener. click to add. And if you navigate your way to this menu, we're going to go, which one do we want to do? Let's choose socket head bolts. And let's do 4762. And now it'll give you a nice little preview of some bolt outlines. But like I said before, we also want a washer to go with this bolt. And if you see in this menu here, see how the bolt is on top? And see how there's a add a fastener there in between it, and see how there's the drilled holes? This is actually representative of what the connection looks like visually. So we have the bolt on the top, right? And then the space here, and then we have the hole, and then a space on the bottom. And basically these spaces here on the between the bolt and holes and at the end allow you to place washers in them. You can place washers on both ends. For now, I'm just going to place a washer on this end. And look, I already have it selected. As long as you can navigate your way to washers, click ISO. I'm going to use the same ones as before, 7089, and it shows up in the preview. So that's cool. That's exactly what I want right now. If at this stage you can't click apply or OK for some reason, just go back and reselect your surface, your point, and termination, and make sure everything is okay. Because sometimes if you click too many times, the program can get confused. Basically, once you're done and you click apply, exit out of the menu, look, you have these bolts. As long as you did everything correctly, it should look like this. And now our part is still isolated, so let's go back to it. You can actually just right click. I believe you can right click anything. Any of these parts that are grayed out. As long as you right click anything, you can actually undo isolate. It makes it super easy to navigate for you. And bam, this is exactly what we wanted. Our assembly is done. Thank you for tuning into my video of the Workshop 2 assembly. This is my first time doing this, so if you have any suggestions, please let me know. If you liked the video, please let me know. If you want more of these and believe they will be helpful, just message Mac Design League on Facebook, or you can email us. We can send some stuff out with this video. Thanks again for watching, and have a good week.